Conditional probability. The sample space for an experiment must often be changed when some additional information about the outcome of an experiment is received. The effect of such information is to reduce the sample space by excluding some outcomes. This means that if we find the probability of some event not on the basis of the whole space but on the basis of the subset of the sample space, the probabilities associated with such reduced sample space is called conditional probability. For example, in a die throwing experiment, the sample space is 1, 2, 3, 4, 5, 6. If suppose we interested to find the probability of even number 6, so let A is equal to set containing 6. If we find the probability of A on the basis of the set S, then the probability of A is equal to 1 by 6. But in conditional probability, we find the probability of A not on the basis of S but on the basis of the subset of S. Suppose that subset is B and B containing all even number of sample space S. If we find the probability of this set A on the basis of set B is called conditional probability and is represented by probability of A given B. In this case, probability of A is not equal to 1 over 6 but 1 by 3 because the total outcome is 3 and the set containing only one element. So 1 divided by 3 is the probability of A. This is called conditional probability because we find the probability of A not on the basis of S but on the basis of set B. Mathematically, if A and B are two events in the sample space S, suppose A and B are two subsets of set S, if probability of B is not equal to 0, then the conditional probability of the event A given that event B has occurred written as probability of A given B and is defined as this one. Conditional probability is represented by probability of A given B and is equal to probability of A intersection B divided by probability of B. This is the definition for conditional probability. We find the probability of A on the basis of B, not the whole space S. So, probability of A given B is equal to probability of A intersection B whole divided by probability of B. Now, we are going to solve the example for conditional probability. If two coins are tossed, what is the conditional probability? What is the conditional probability that two head result? We are interested to find the probability of two head occur and suppose that the set name is A. Given that there is at least one head occur, in the example 3 sets are given. Number first, two coins are tossed, then the sample space is this one, head tail, tail head and tail tail. So this set represent the sample space. Second set is the two head result. The HH represent two head result. Suppose set containing HH is equal to A. And the third set is at least one head occur. In the sample space, there are three elements there are at least one head occur. So head, tail and tail head, this is the another set, this is the third set, and we represent this set by B. If we find the intersection of A and B, so A intersection B is equal to head, because head and head are common element in these two sets. Probability, if we find probability of A, so probability of A is equal to 1 over 4 on the basis of the sample space, not on the basis of B. And probability of B on the basis of sample space S is 3 by 4, because in set B there are 3 elements and the sample space total elements are 4. Similarly, probability for A intersection B is 1 over 4. For conditional probability, formula for conditional probability is this one. Probability of A given B is equal to probability of A intersection B divided by probability of B. Probability of A intersection B is equal to 1 over 4 and probability of B is equal to 3 by 4. So 4 will be cancelled to this 4 and our result is 1 over 3. So probability of A given B is equal to 1 over 3. If we find directly probability of A on the basis of not the sample space S but on the basis on the set B, so there is one element and set B have 3 elements, so 1 over 3 probability of A on the basis of set B is equal to 1 over 3. So conditional probability of A is represented by A given B and the value of conditional probability is 1 over 3.